Okay, well, we are back now with the second part of this introductory content. And left where we left off was asking this question of whether or not we just have five senses, right? So got the usual five senses listed here, right? Uh, Vision, hearing, touch, taste, and smell. So, we have the question mark here because we might ask, as we do at the bottom here, Uh, is that all? Could there be more than five senses? Or alternatively, might there be fewer? And why would we suggest such a thing as that even? Well, we'll get to that in a second. Brief note, the common term for talking about the different senses is to talk about sensory modalities. So vision is a modality, hearing is a modality, um, and so oftentimes you might see in the literature, we'll talk about things like cross-modal matching. What is that? Well, some things what we can do in the um, introductory video I made for the course where I talk about the different papers. Um, in the brief paper assignments, I talked about some experiments where you could do something like create 4 or 5 different cups of water with different concentrations of sugar, and you could have people rate the intensity of the sweetness on some numerical scale from 0 to 100. We might consider that to be an example of cross-modal matching. It's a bit of a stretch. It's an odd method. But what you're trying to do there is you're trying to match a taste experience of sweetness to a number. And so there's a mapping there that is, it crosses modalities from taste experience to numerical magnitude. Now, let's try something else. Let's say, for example, that I gave someone a volume knob on a tone generator. So I just have some kind of a device that makes a tone, right? Just simply is a beep kind of a tone. It just plays this tone continuously, right? So now what I want to do is I want to have you drink a little bit of my sugar water, and maybe it's the weak concentration of sugar in the water. And what I want you to do is I want you to adjust the volume knob on the tone generator to a level that is appropriate to match the perceived sweetness. That's a strange thing to do, maybe, right? But the idea is that you might set it to a low volume level. So to go with the weak sweetness. But if I then give you the other cup that has a high amount of sugar in it, so it tastes really sweet, and then I want you to change the volume settings. Now you're going to turn up the volume really loud, beep, to go with that more sweet. And so the idea is that you could do like this kind of weird mapping to see, is there a systematic relationship between variations in sweetness that maps cleanly and linearly to the volume settings that people select, right? And that's called cross-modal matching, because what you're asking people to do is to match the intensity of a sound stimulus to the sweetness of a taste sensation stimulus. Why you would do such a thing, these kinds of studies have been done in the history of sensory research. The results that they yield are a little unusual, and but we can, in fact, mathematically quantify them. And we see that there's all these weird nonlinear relationships. What does it mean? And does it tell us anything useful about perceptual experience? Is another question entirely. But nevertheless, this is where we see the word modality come up sometimes, right? With the cross-modal matching experiments. Now, let's get to the question of, are there more? First, how do we define sensory modalities? We can go back to, it was Aristotle that gave us our 5 senses, but we need to think about the criterion that we use. So we can base it on anatomy, right? And so we say, well, the eyes, that's a distinct anatomical feature. and it's distinct from the ears, and which is distinct from the nose, and distinct from the tongue and the mouth. And that's distinct all from your skin, which contains all of your touch receptors. So because we can anatomically identify 5 different sensory organs, eyes, ears, nose, tongue, and skin, then maybe we can identify 5 senses in this way. But we might also then think about, well, wait a minute. There are other sensory organs, even if they're not so plainly obvious. And that would entail things like the vestibular system in your inner ear, which is very close to and very similar in its functionality in certain ways to your hearing, but it is not responding to sound waves in the environment. It responds to the position of your body relative to gravity and any other accelerational force that's applied to your body and head, especially. So, but it's a distinct organ in the inner ear. And so anatomically, it is separate. So again, we could ask, well, that could imply a 6th sense here. Usually we say 6th sense is something like ESP, but we have no organs for that. But we do have one for the vestibular system, right? We also have organs in our muscles and tendons that respond to the stretch of our muscles and tendons when we move our bodies around, as you see me in the little window here, right? Camera window. That requires us to move the limbs using muscles. And as the muscles change their length and the tendons, which attach the muscles to the bones, stretch, that activates stretch receptors that are embedded in the muscles and tendons. This is called proprioception, and this helps you perceive your body's position and movement. There's also pressure receptors embedded into your joints, so that when your joint is at some angle, like I bend my elbow like this, for example, now my elbow is at an extreme angle, and I can feel quite a bit of pressure in the elbow joint. And that's also, these are distinct receptors. Now, we might think that that's all part of touch, and maybe it's fair to say that, yeah, okay, touch is just about using all these pressure receptors in our skin and muscles and so forth. But anatomically, they're not in the skin, right? So they're in other anatomical body parts, muscles, tendons, and joints. So are those all then anatomically different receptors, and so and therefore different systems, different modalities? So if that's the case, then what we would need to do is add more to the list, right? What about other receptors? For example, you have similar kinds of stretch receptors embedded into your digestive system, so that when you eat a large meal and your stomach is distended, you can feel the fullness from that, right? And you can also feel the rest of your digestive tract if you have any sort of gastrointestinal illness and you get cramps and other kinds of feelings from that. Well, of course, you have that feeling of butterflies in your stomach or nausea and all that other stuff. It comes from internal sensory receptors embedded into your digestive system. So are we going to say this is called interoception, the perception of your internal organs? And so anatomically, then, those are distinct. You also can feel it when your heart's racing. And so again, that's because there's some receptors, touch receptors in the cardiac area. Also, we have receptors embedded into our arteries. And so when your blood pressure is higher, your arteries expand. Now, do we consciously feel that? That's probably something that we may or may not be able to do, although maybe we might be able to, using biofeedback, we might be able to learn how to pay attention to that and actually feel it when maybe if our blood pressure is really, really high, we'll feel it. Although they usually say that high blood pressure is the silent killer, right? Because nobody really notices and realizes they have high blood pressure unless they measure their blood pressure reliably. But anyway, we may not consciously feel that, but nevertheless, your body actually does try to regulate your blood pressure. This is part of what regulates the thirst system, right? When your blood fluid drops and you're dehydrated, your blood volume drops and your blood pressure drops, and the blood vessels themselves constrict. And receptors embedded in the blood vessels are part of a sensory system that then drive the brainstem to say, hey, this person needs to drink some water. make them feel thirsty, so they drink water. And then as you do so, that causes your blood volume to increase and your blood pressure increases and the arteries expand. And that then sends a signal back to the brainstem to say, all right, we have enough water. It's time for this person to not feel thirsty anymore. So we have this little bit of a looping here, a feedback loop that does in fact rely on sensory input from the arteries. Again, it's not part of conscious perception, but it still is a sensory modality. So how far can we go? We could call that interoception as well, but it's clearly distinct from the digestive system. It's the cardiovascular system. So on and on we go. By the way, here's one that one wants to think about: the taste buds in your mouth that you use for tasting food. We also find them all throughout the digestive system. But we don't consciously taste what's happening in our intestines, probably thankfully for that, right? But there are still similar receptors there in the intestines, and they serve another function, which is to detect the nutritional content of the food. When you have a high-fat meal, for example, taste receptors in the intestine detect the higher fat and high caloric content of that, and that regulates certain hormones related to feelings of fullness. So again, these are sensory receptors all throughout the body here that do various things. Technically, then are anatomically distinct. So we might think, well, anatomy is the wrong way to go about doing this. Maybe what we want to do is we want to focus on what's called phenomenology, which is more about the perceptual experience. And so phenomenology is about, well, what am I experiencing right now? Right. So if and there's of course this brief paper assignment number 1, right? A sensory analysis is to think about the phenomenological experience that you're having. What kinds of experiences do I have visually? How can I describe visual sensations? Well, as we notice, we tend to describe visual sensations in terms of something can appear bright, or maybe it's not bright, so it's dim. So there can be variations in brightness of visual sensations. There can also be variations in color, right? We can talk about whether it's red or blue or green or any other color, but so there's variations in that. And that seems to be somewhat of a limit. Obviously, we can describe more complex visual experiences, such as objects and naming objects and space and distance and size and shape and these kinds of things. But at the very basic level, visual sensations tend to be described phenomenologically as variations in brightness and color. That seems to be the way that we could simplify and reduce vision to its very essence. The visual world itself is an array of brightnesses and colors throughout the visual field that are somehow integrated into becoming a coherent perceptual whole. And we have to figure out how to take those sensory experiences and turn them into that coherent perceptual whole. We're talking about that at the end of the first part of the video here. Now, what about hearing? Can I describe sounds in terms of their brightness and color? Well, sometimes we can talk about what's called synesthesia, in which these words that come from one sense seem to sometimes apply to other sensory modalities. But that's a strange and unusual and moderately rare phenomenon, so let's not go there too much. Generally speaking, words like brightness and color are unique to visual experiences, not to hearing experiences. So therefore, how do I describe auditory sensations? Well, loudness is more appropriate here. It seems to have an analog to the concept of brightness and vision, but instead of calling sounds dim and bright, I call them quiet and loud, right? And then also pitch, right? Because we can have high pitch tones and low pitch tones, and that might be an analog to the color dimension of vision, but I don't say that sounds are red and green and blue. I say that they're high pitch, low pitch, so forth, right? Or if I'm a musician, I might even describe them in terms of their musical notes and what kind of key they're part of, or musical mode they're part of. But otherwise, I don't, describe them in color terms per se, right? And for touch, right? How do you describe touch experiences? I might describe. Depends on the kind of experience, but if I'm holding an object, I'll get my coffee cup back here, right? I can feel its temperature, so cool versus warm. is a way of describing a touch experience. Smooth versus rough or coarse is another way of describing. If I move my hand across it, this is smooth, right? So that's another way to describe it. Or if it's an object that I can wrap my hand around, I can squeeze it and I say it feels hard or rigid, right? But if it was a sponge, then I might say it feels squishy and soft. Or if it's Play-Doh, then it's a different kind of squishy than a sponge is, right? So in terms of its resistance and all of that. Or if I have my hand in liquid splashing around in water, then that's a completely different kind of resistance to my squeezing it and holding it and moving around in it and so forth, right? What about taste and smell? So again, we have intensity issues here for taste and smell. A smell can be strong or weak. A taste can be strong or weak. But calling it loud and quiet or bright and dim doesn't seem to quite be appropriate. So we just say strong and weak. And then for taste, we tend to think about basic taste sensations. And it's kind of like primary colors, but instead of saying red, green, and blue and yellow, we talk about sweet, sour, salty, bitter, savory as elementary taste sensations. And it seems to be somewhat sensible that we can bite into an apple and say, yeah, I can describe this in terms of how much sweetness there is and how much sourness there is, which may or may not depend on whether it's a sour green apple or unripe apple or whatever, right? Can you do the same thing for smell, right? So if it's one thing to talk about biting, I have a chocolate in the background of the slide here, so you can bite into a chocolate and you can report some degree of sweetness and bitterness from the chocolate, depending on its cocoa content and all of that. Any other things that might be inside of it that might add a extra little tinge of acidity or sourness. You can also put a little salt crystal on there. Sometimes a little salt helps amplify the sweetness and maybe adds its own component. But when you analyze smell, I smell a chocolate. Can I break that experience down into how much sweetness or bitterness I can smell? I can taste the sweetness and the bitterness when I eat the chocolate, but it doesn't quite work so well to say that I can smell the sweetness and the bitterness or the salt or anything like that. So it seems that when I smell chocolate, I usually just say I smell chocolate, right? I don't smell. It's harder, right, to analyze my smell experiences down into elementary odors in the same way that I can analyze a flavor experience down into elementary tastes, right? So that's a hard thing to do. Now, another thing that we can try to do is we can try to redefine our sensory modalities in terms of the external stimulus that they detect, right? So the eyes are responding to light, electromagnetic radiation, a particular band of the electromagnetic spectrum. The ears respond to sound pressure waves in the air. So whenever there's a sound producing event, like I clap my hands, and that causes a pressure wave to spread through the air, that triggers receptors in the ear. Touch responds to the mechanical stretching, pushing, and pulling of receptors embedded in your skin. And we can also maybe throw in the concept there of integrating touch with proprioception, those receptors in the muscles and tendons that I talked about, because all of that pressing and pulling and stretching of the body involves stretching the skin as well as the muscles and tendons. So therefore, the external mechanical forces that are applied to our body from the world are detected by different receptors embedded throughout all of these different places, but they're all responding to the same external mechanical forces applied to our bodies. So we can then integrate and say that touch, proprioception, joint sense, and everything that I talked about earlier are really just one system. And maybe, just maybe, it could be valid to include the vestibular system of the inner ear, since that is detecting gravity as an external force acting on our bodies as well. So again, all external forces acting on our bodies can be united into a touch system that is really more defined by the external world rather than the anatomical locations of the receptor itself, or our phenomenological experience of those receptor activities. Same would go for taste and smell, because all of those chemical receptors in our digestive system that we're not even consciously aware of, which would therefore seem to not even be allowable as a sensory modality, but they are still detecting chemicals, because that's what the receptors in the taste buds are. They are chemical detectors. They respond differentially to different kinds of chemicals in foods that we eat. And likewise, the smell receptors in the nose are also chemical receptors that respond to different kinds of chemicals that we inhale. So if we talk about these as all what we might call chemosensations or chemoreception, then taste and smell and all of the other internal things are all part of the same sense, because it's all chemical reception. Same goes, by the way, when I was talking about touch and the vestibular system, that all of the stretch receptors embedded into the digestive system and the cardiovascular system are all responding to mechanical forces. So again, because of that commonality, then they would all fall under that number 3 in the list here. So here what we're doing is maybe reducing, because we could say taste and smell are reducible to one chemical sense. Can we go further than this, though? This is where I'm always reminded of this. When I took my qualifying exams, I have a sensory psychology PhD, so this is my thing. And when I took my qualifying exams as part of my PhD studies, I had to write a question, basically like this. And I entertained all of these options and explained all of these views. And then as the last option, and I remember the professor grading this basically said, "I'm going to ignore your last paragraph because it was nonsense." But I didn't think it was nonsense, and I'm still going to talk about it. So let's go back to my coffee cup prop here, right? I can look at this. You can look at it in the little camera window there. So you see that it is a coffee cup. It's green, a little shiny, a little bit of light reflection on there, right? Now, what you are not able to do is touch it, but I'm touching it, right? And so as I look at it and I touch it at the same time, I am having 2 different experiences. I am seeing its shape and size and its glossiness in the light, but I am also touching it and I am feeling its smoothness and its shape, right? The way I feel its shape corresponds to the way I see that it's shaped. So I'm experiencing one object here, right? I'm not experiencing a visual object and also a touch object as 2 separate experiences at a conscious level, right? It just becomes one thing in my perceptual awareness of it, which is it's a coffee cup. And it has various properties that I experience as all unitary, right? That's all part of one thing. And the feel of its surface is consistent with and is really the same thing as the look of its surface, right? It looks glossy and it feels glossy, and that's just its property. It's all part of the one thing itself. So in a way, what happens is that when we experience the world through all of these many different sensory modalities, we are not having multiple experiences somehow superimposed on each other. We experience the world in its entirety all at once as a unitary experience, or percept is another way to talk about that. And so that then is our conclusion here, is how many senses do we have? Well, it depends on how we want to describe it. It could be at the anatomical level, as I mentioned. It could be at the level of phenomenology, of how I describe these experiences. Describing vision is different than describing hearing or touch or taste or smell. It could be at the external energy level, is what are the kinds of things in the environment, that's 3 now, that stimulate these receptors. Or number 4, it could be at the perceptual awareness level of just it's all unitary, and we're just going to say there's just one modality. Now, my professor didn't like that answer, and maybe you don't either, but at least there's another candidate. So we could have as many as 4 candidates for different ways of counting sensory modalities. How important is this discussion? Maybe not really very much, but one thing that is important about all of this is when it comes to the phenomenological answer, which is actually one of the more popular answers, this whole idea that vision seems to be defined by unique qualities like brightness and color, and hearing is defined by unique qualities like loudness and pitch. that these are the things that sensory psychologists like to study. What are the properties of light that determines whether it is bright or dim, and how bright is it? Or what color is it, right? What's the relationship between the wavelength of the light as a physical measurement and the color that a person sees? What's the relationship between the frequency of a sound wave and the pitch that a person reports hearing? What's the relationship between a specific chemical compound and the specific kind of taste that a person reports tasting, sweet, sour, salty, and so forth, right? These are the kinds of things that really form the foundation of a lot of sensory research. This research is called psychophysics. And so in psychophysics, what we're trying to do is we're trying to map the physical stimulus intensity or physical stimulus attribute at all to a psychological response, right? The intensity of the light maps to a psychological response of brightness level of some degree. The wavelength of the light is a physical description that maps onto some psychological response called color. And the goal here is to try to figure out how can we map those things from physical to psychological, because maybe that's going to teach us something about how the sensory organs themselves work, right? Each one of these sensory organs has to respond to that physical stimulus and convert it into something that the brain can make sense out of. And we want to understand that very first stage of sensory processing. How do these organs take the stimulus energy and do things with it? And that's the goal typically then of psychophysics. But then the next thing we need to do, though, is we need to go from the sensory level in the psychophysics research to talking about perceiving that world, right? Like I said, I just perceive the coffee cup. And that seems to be something that transcends the specifics of the sensory modality and everything becomes unitary. So at the level of the sensory stuff, we're going to keep our modalities separate, and we're not going to go with my flaky idea that there's only one modality. There's somewhere around 5 modalities, but somehow or another, they all become integrated into a unitary perceptual whole where I see the coffee cup, or in this case, maybe a tree. I think this video has gone on long enough, though, so we will cut it here, and we will come back and pick it up now by talking about perception. Go from sensation, now what we just did, to perception next.